Good day, this is the Professor, CBMD PhD, and today's Friday, June 23rd, 2023. It is 4:00 and 32 seconds, AM Eastern Standard Time, and today's research, Supernova. So let's hop to it here. Molecular filament shielded young solar system from Supernova. Date June 22nd, 2023. Source: National Institute of Natural Sciences. Isotope ratios found in meteorites suggest that a supernova exploded nearby while the sun and solar system were still forming, but the blast wave from a supernova that close could have potentially destroyed the nascent solar system. New calculation shows that the filament of molecular gas, which is a birth cocoon of the solar system, aided the capture of the isotopes found in the meteorites, while acting as a buffer protecting the young solar system from the nearby supernova blast. As primitive meteorites preserve information about the conditions at the birth of the sun and planets, the meteorite components show an inhomogeneous concentration of a radioactive isotope of aluminum, and this variation suggests that an additional amount of the radioactive aluminum was introduced shortly after the solar system started forming. A nearby supernova explosion is the best candidate for this injection of new radioactive isotopes. A supernova that was close enough to deliver the amount of isotopes seen in meteorites would have also created a blast wave strong enough to rip the nascent solar system apart. As stars and large groups called clusters inside giant clouds of molecular gas, these molecular clouds are filamentary. As small stars like the sun usually form along the filaments, and large stars, which will explode in a supernova, usually form at the hubs where multiple filaments cross. Assuming that the sun formed along a dense molecular gas filament and a supernova exploded at a nearby filament hub, the team's calculations showed that it would take at least 300,000 years for the blast wave to break up the dense filament around the forming solar system. The components of meteorites enriched with radioactive isotopes formed in approximately the first 100,000 years of solar system formation inside the dense filament. The parent filament may have acted as a buffer to protect the young sun and help catch the radioactive isotopes from the supernova blast, wave and channel them into the still forming solar system. And this is a Professor of Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.